And now returning for the third year in a row is Bob Moore. As mentioned earlier, he is Director of Server Software at Hewlett Packard Enterprise Server Division. As a Lieutenant Colonel in the Army Reserve with the U.S. Army Special Forces Command, Bob has been deployed to Iraq and Afghanistan, rebuilding infrastructure and managing IT systems. Bob has been in the IT industry for over 20 years and managed teams at Compaq Computer Corporation, Hewlett Packard, and now HPE. His team leads the initiative for incorporating cybersecurity protection technology in servers, networking, and storage solutions. He is also responsible for the new and distinctive program called InfoSight for Servers. InfoSight delivers artificial intelligence to HPE's portfolio of ProLiant, Apollo, and Synergy servers.
And let's go to the next slide, and I'll give a little bit of an overview of what artificial intelligence is. And then we'll tie this into how cybersecurity is being impacted by artificial intelligence and how we're using it actually to help against modern day hackers. So if we can go to the next slide, I'll give you a little overview. Okay. So we have two approaches to artificial intelligence. The first is the top-down model, and probably some of you are familiar with that. It's what you would normally think of when it comes to artificial intelligence, and it's simply creating a bunch of rules or algorithms that are commonly referred to as artificial intelligence, and then using those rules to help determine or predict what an outcome might be. So if you click down one more time, it shows how we use this current condition. The current condition then gets established, and you might think of this like, in a weather pattern predicting scenario, where the current condition is used. You've got today's weather, and then you use some algorithms and rules, and then you get a prediction that is an outcome that you see coming down at the bottom of that. So that's a classic artificial intelligence operational model. And what it does is the more sophisticated the algorithm, the more accurate those predictions can become. Naturally, we see a lot of companies using that. Sometimes it's called rules-based, but it really is a top-down. It's much more sophisticated than just a series of rules. In a weather forecasting approach, you might say, if there's a high pressure system and it happens to be the month of October, and then it's that high pressure is moving in a certain direction and it coincides with all these other weather conditions, then we can predict that this might be the outcome here for the near future. It turns out that that's fairly successful artificial intelligence way of predicting and modeling for the future. But there's another way. It's the bottoms up. So one more click will show you how this happens. It's the bottoms up model. So what this is artificial intelligence that says, just forget all the rules. We don't need to have the rules. We can simply have some type of bottoms up data set that creates a whole series of big data information and feeds that in. So what happens is we collect huge amounts of data year after year after year. And it turns out that this is actually a little more accurate way of creating a predictive model. So now, instead of creating a whole bunch of algorithms, a series of algorithms that would make you try to follow these rules to predict an outcome, you just collect significant amounts of data. And through that data, then you can actually have a better predictive model. So it's called the bottoms up approach, and you can see there it is. You get a prediction out of that. So now, over collecting data from the last 100 years of weather information here in the Houston area, we can actually make a more determinative prediction using this huge data, and it is large sets of data, which is the only real concern. Is it significant amounts of data that we're using and collecting to make these predictive outcomes? But there's two different ways and approaches, both of them very legitimate. But as we're seeing, we actually come up with a little more accuracy from the bottoms up approach. Same way in pharmaceutical or medical, we see that you can have some predictive algorithms that might diagnose something. On the other hand, if you have a huge set of data, it actually becomes more and more accurate in predicting by sorting through that data. And there's both structured data as well as unstructured data that gives us the ability to predict the future. So on the next slide, we'll look at some examples of this.
Bob, may I intersect for a minute? It might be easier for the load on the internet. You've got a little bit of a weak connection there. So if you turn your webcam, do a stop cam, I think that might help and then just we'll project the screens and then we'll bring you right back for Q&A.
Okay. So there's the two approaches, as I mentioned, and here's the tops down with the rules, and then at the bottom there you can see the bottoms up approach. And this is where we get into machine learning and even deep learning. And in deep learning, that's where you get the neural networks that really start to be ultra predictive. And then we have two sets of data that we're using: supervised, or what we commonly refer to as structured data, and that's generally categorized and structured, and that can be very easy to sort through. And that creates, a bit of this deep learning that we're trying to get to. And this is a very, very strong form of artificial intelligence. Let me give you an example what deep learning can actually get us to. So you've all used probably Google Maps, and that Maps then offers some other suggested routes based on the traffic conditions, and that's a little bit of artificial intelligence happening there. But when we get into deep learning, that's when we see in the future artificial intelligence really becoming very powerful and creating not only your ability to see the most optimum travel route to the destination, let's say the airport, but this is when deep learning will actually see an appointment, for example, on your calendar in a week or two with a customer and arrange for travel to the airport or optimize your trip to the airport. It'll actually book your flight, check you into the flight, and then make a reservation at the restaurant where you're going, which they know the artificial intelligence machine learning knows is your favorite location. So this is the direction that AI is going towards. Very helpful and a large, almost like your own virtual personal assistants. You can actually have everything scheduled just based on the fact that your calendar has an appointment with a customer in a different city, and so you get a flight arrangement. You even get a wake-up call on your cell phone with the alarm, making sure that you get up in time to catch the Uber to the airport, which has all been prearranged, and then you've been checked into your flight. You just walk right onto the plane. You get yourself to the meeting because the artificial intelligence has arranged for transportation at the other end of your journey, and then you've got your reservation booked for you based on all of your patterns, your restaurant dining habits in the past for your favorite location. So it's really getting to the point where AI can be exceptionally helpful to us, not only in that particular one scenario, but in many others, like in a driving scenario. Now, where this artificial intelligence becomes really most helpful is when we add this huge data set called unstructured. So with one more click, you can see that we've got unstructured, and this really helps and compounds and accentuates the deep learning capability. So now what we have is both structured data and then unstructured data that are coming together to provide huge sets of learning. And this is how, through all this huge sets of information, we can be much more predictive and much more accurate with coming out with predictions using artificial intelligence in the future that really will be essentially almost 100% on the spot. Now, why is it so important that we're absolutely totally accurate with artificial intelligence? Well, it's because when we get to things that really depend on very accurate artificial intelligence, it's going to be safety and security that come into play. So let's take a look at the next slide. And I think this will be a good example here of what I'm talking about. So it's really important that artificial intelligence, when it comes to auto-driving vehicles, as you, I'm sure, agree, needs to be 100% precise and accurate. And that means that those vehicles have to have instantaneous ability to make decisions for you. And that's why there's generally some type of, and with no latency, that's why there's almost always some type of server or compute product device located on the vehicle itself. Now, imagine, if you will, those two scenarios of artificial intelligence that I laid out for you. One is the rules-based, and the other is the high data set of both structured and unstructured data. Well, if you were trying to make a series of rules or algorithms that were completely predictive, 100% accurate on a vehicle on what to do, it might be difficult to anticipate every single scenario that a vehicle would come up against, right? Because there's so many different, globally, so many different road conditions, hazard conditions, and almost difficult, really difficult, if not impossible, to have enough rules, enough algorithms to be 100% accurate. And so what we see happening is these large sets of data then actually become much more accurate and efficient in predicting what that vehicle should do if there's no lines on the road or something like that, where rules-based artificial intelligence may not be able to capture that. And the way this happens is, of course, you have to have no latency with the artificial intelligence and the decisions that vehicle has got to make, because instantaneously it has to be able to depress the brake or move one direction or another. But then also, if you add unstructured data from other vehicles, when you plug your vehicle in at night, you think that you're recharging it, and really what's happening is that vehicle of yours, that auto driving vehicle, is actually learning. So it's learning by downloading all of the information that's learned. Now, it doesn't pull all the unstructured and structured data down into the vehicle, but all of the learnings that come from that do then get put into the compute product, the processors, the servers that are in that vehicle. And we can actually then start to learn from other vehicles. They could be a different brand. And then if we cache all that information through a series of cloud-based servers and storage information, we can actually share huge amounts, because think of all the number of vehicles on the road that have actually come up against every single type of scenario that you might encounter in a driving condition. So now we have the ability to be very, very accurate with the predictions, and the ability to tell the vehicles, the auto driving vehicles, exactly where to go and what to do and how to respond based on millions and even billions of data sets of information and what's happened to other drivers. So this is when using this structured data that might come from same brands or same vehicles sharing information quickly, but then also lots of unstructured data coming from all sorts of different types of driving vehicles around the world. We can use this to create truly more deep learning, where we get more of the neural network learning capability and artificial intelligence opportunities. Now, this then starts to tie in a little bit with our security capabilities and predictive requirements, because as I've talked to personally auto insurance companies, the fastest growing component in the insurance industry is actually not home or auto or some of the more common one. It's cybersecurity insurance. And that's because as these auto driving vehicles, now powered with artificial intelligence, large sets of unstructured and structured data are out there on the road, the thing that needs to be protected more is now not the driver necessarily or the vehicle, but it's the information that is generated and downloaded to those servers. And therefore, the insurance needs to be more on the software and the data that's coming into the vehicles. And that's why cybersecurity is more important, because we've seen in a couple of occasions where hackers have been able to get into firmware, for example, on some vehicles, and they can take over and actually drive those vehicles. So making sure that that doesn't happen is the real key for, and covering that, if it were, is the key for cybersecurity insurance, which is why they're getting out of, or at least the auto insurance company I talked to was migrating away from auto insurance and actually into cybersecurity insurance, because now what you have to protect is all the data in transit, all the information, the networks, the neural networks that we're developing to enable us artificial intelligence. And this is really an up and coming field, along with and supporting cybersecurity protocols and capabilities and technologies as artificial intelligence takes over, ensuring that intelligence, that data, is really the direction that most insurance companies are going. On the next slide, then, it gives you a little glimpse as to what's happening there with our cybersecurity insurance. and the fact that there is a big consortium of 8 of the world's largest insurance underwriters that have actually come together to insure cyber products and cyber components. It's called the Cyber Catalyst designation, and you see there that Marsh Insurance Broker is the one that's pulled this consortium of the world's 8 largest cyber security insurance providers together, and then they had created this Cyber Catalyst, and this was issued. These Cyber Catalyst designations were issued in September of last year, are in effect now. HP, yes, does happen to have 2 of those designations of the 150. There were 17 that were awarded, and HP does have 2 of those. But not to get into that very much, just the point here is cybersecurity insurance, as we see the rise of and the escalating threats and attack vectors in the world today, the insurance and being able to insure those devices that are using artificial intelligence against breaches is really an up and coming trend that everyone is looking at and evaluating. And so it's difficult for these insurance underwriters to create some type of risk assessment when all of these, with the expansion of artificial intelligence and all the data that's used, it's difficult to do a real solid risk assessment unless those products and services are using devices that have a Cyber Catalyst designation, because it's obviously being recognized by the cybersecurity insurance underwriter. So it's helpful and certainly also provides those users of Cyber Catalyst to have and benefit from enhanced terms and conditions. Now let's take a look. One more thing that's compounding this or exacerbating this. So we've got artificial intelligence, we've got remote driving vehicles, and this talks to the fact that we've got a massive migration to the intelligent edge. Where do you think most of the artificial intelligence devices are being used? Well, it turns out they're out there on edge devices, because that's where they're most needed, in a vehicle that's out on the edge, in a pump or a controller device that's located out on some type of remote oil and gas facility. And so having the artificial intelligence locally there so that it can make instantaneous decisions without any latency is key. But also then being able to upload that information to a cloud base, as I mentioned with the vehicles, is really key, so that all those intelligent devices can learn and can update all those AI rules and information and data learnings that have taken place is really key. The point on this slide is that we know that a full 70% of this data, and as you see and can imagine, we're talking about huge terabytes of data and information being stored. All that information, 70% will be not in a data center or even in a cloud, honestly, but stored out there on edge devices, and then backed up by information in the cloud. But it's important that all the edge devices have this type of information. And the issue that we see from a cybersecurity as well as an AI perspective is this is where all the attention is going, because this is where all the information is being stored. And compounding that concern is the fact that these are probably the least protected devices, these edge devices, as you can see there in that smart motor that I've illustrated there. Those are out there without protective data centers encompassing them. They're out there exposed, where a bad actor, cyber attacker, could potentially get access to those, physical access, much more easily, and develop some type of malware packet that could be then inserted potentially. Again, this is why cybersecurity is so important, as these two factors come together: the advent of artificial intelligence and all this data and information, as well as this migration to edge devices where they're more exposed and really need to be more protected. So we've got to be able to come up with ways to protect and ensure those devices to make sure artificial intelligence, as it moves forward, and especially on the edge, is not interrupted or compromised by bad actors that have nefarious designs. And we see bad actors, especially in today's environment with the current pandemic, using those things, as they do every crisis that seems to happen in the world today, to exploit their bad intentions. And it's really sad to see COVID-19 makes people curious, almost desperate for information. And with COVID, bad actors are using that as a way to deploy phishing devices more effectively, because people are so desperate for updates on a cure or a vaccine that they'll click on links. Because in all of this, it happens to be the human factor in cybersecurity protective capabilities that's the least predictable. We are using artificial intelligence for the benefit of mankind, but we also see that the cyber attackers are using it to breach infrastructures, get through networks, and that type of thing. And it's sad, but never does a crisis go unutilized by these bad actors, be it a pandemic or a hurricane or an earthquake or something like that. We almost always see a spike in cyber attacks during those types of natural disasters. And as more and more equipment gets out there on the edge, and more of this artificial intelligence drives data to the edge, it's really more and more important that that be secured. And we can secure equipment, and we can come up with lots of great protocols and capabilities, but the least predictable is almost always the human element. And we do see, and we know that about 5% of every employee population will click on links, and using artificial intelligence, when the bad actors use artificial intelligence, it actually increases that to a much higher rate, because it can look so official and so legitimate. So on the next slide, we'll talk briefly to how that might happen, what we're seeing there, because it's certainly true and substantiated by some of the research that I've done, and showing that hackers using artificial intelligence are being more and more successful, unfortunately. So we've got to use AI to advance the way people live and work in the world today, and also to keep people safe, which we do. But the hackers, we got to be aware, are going to be leveraging the same type of capability. So in the middle, I was just mentioning the increased phishing effectiveness, and that really raises it from about 5% that will click on a link, 5 to 15, up to 30%. So you can see a huge increase. And why is that? Well, artificial intelligence is being used by cyber attackers to create profiles of you and I and everybody on this call here today, so that those phishing attacks that come in look very real and authentic and genuine. And when people see those, because you've been modeled through your social media, your habits and everything, and a lot of that, as we've let artificial intelligence benefit our lives, also can be used for bad intentions, if we're not careful, by bad actors to create profiles and then create some type of phishing attack that looks like these emails are coming from a legitimate source. And so it's very difficult to protect against that, because that immediately invites the bad actor in. So it's really key in our cybersecurity practices that we manage and try to take care of that human element. And that's a big lesson learned I'd like you to take away from this presentation, is that helping to train employee populations in any company or agency is awfully key to helping to manage that artificial intelligence threat that we see making phishing, and therefore inviting ransomware or malware in very effective. And it's unfortunate, but it is happening today. We also know that we've got to be able to design into products and services the ability to detect that, because of these efforts of AI, through AI, of bad actors to get in now more effectively. We've got to be able to detect that bad actor once they're in, and then recover from that. So it's no longer just sufficient in a cybersecurity world to have great protective defensive measures, a firewall, but you've got to have the ability to verify everything. And there's a new term in today's lexicon called zero trust, and that means we don't trust anybody or anything. We continually verify everything, and that's what we're having to migrate to, because we're making sure that everything is checked all the time. And if there's any type of nefarious activity or behavior facilitated potentially by AI through a bad actor, we can determine that, route it out, detect it, and then recover our systems from that. And it's particularly needed in areas where artificial intelligence is used, like auto-driving vehicles. Some other examples there on the left, you can see that getting through some of those CAPTCHA devices is pretty easy using artificial intelligence, as well as on the right-hand side, the extensive use of malware, and making sure the malware packages don't deploy right away, but they wait until they get to their intended target, because using artificial intelligence, you can make sure that a payload that a bad actor creates only executes when it gets to the place it's supposed to be. So a lot of use, unfortunately, of AI by bad actors out there in the world today, but we're battling against that, and we know we can stay a step ahead of them. But artificial intelligence used for good, as well as, unfortunately, in these cases, for some bad. So I'm about out of time. I appreciate it. Sorry it took me so long to get logged in. I'll leave you with one final frontier when it comes to really edge devices and getting artificial intelligence in use in really remote locations. So in the next slide, you'll see that we have with HPE, the Intelligent Edge. Of course, we've deployed a computer, a server, one of our compute products, Apollo products, on the space station, and that's using, of course, all sorts of advanced capabilities and technologies, which I really cannot go into publicly here, but we're proud to be part of those developments, as well as being part of all the advancements with auto-driving vehicles, and artificial intelligence is certainly a big initiative for us. One more click down and you can see the awards that we received for that. And with that, I think, Umesh, that's about it for my presentation, and I'm just on time. So I appreciate this. Thanks, everybody, for listening to my presentation on artificial intelligence, and hope that it gives you some solid information on where things are going, or at least piques some of your interest. One more slide down, and if you have any more interest, you can click on some of the links that I've got on that last conclusion slide, get more information on artificial intelligence. But it certainly is a fascinating area. I think you'll agree that's advancing the way all of us live and work, and at the same time, unfortunately, being used by cyber attackers. So we've got to be careful in that regard.
So Bob, awesome presentation, always full of great content.
You establish and market trust with AI and provide the confidence and limits on systems predictive capability. That's really great thought, because what we see is a lot of people concerned about this seems to be perhaps more intrusive than what we would like. Perhaps it's a little bit like Big Brother watching, or always knowing what you're doing, and that's maybe a little bit overbearing. And how do we create trust in that environment? Well, the first thing that we've had a lot of conversations on that, naturally, is we're a big proponent of forwarding the artificial intelligence. The first thing that you've got to do to create trust is, first of all, you have to make sure that there's no nefarious designs or intents with using artificial intelligence. So for us, that means keeping the bad act the first thing you have to do to help create trust. Nothing will ruin the trust of artificial intelligence more quickly than if the bad actors are quite successful in getting information that they really should not have any access to. So we're marketing the a system's ability to stay safe based on all the capabilities, security capabilities that we're building into artificial intelligence, a lot of checks and balance. And then the second part of the question, I think, is how do we perhaps limit a system's prediction capability? Do you really want the artificial intelligence to know everything about you? How far do we go in letting them profile you? It's a lot of information. Do we feel comfortable with that? And our simple answer, and maybe not as simply executed, has been to try to make sure that the limits can be established by the user, and therefore you have to be able to opt in for these type of capabilities. Once customers learn to trust the artificial intelligence that's out there, and realize that it's secure and that it's safe and it'll work, it's much like auto-driving vehicles. It's going to take a little while before people are really comfortable realizing that those cars can drive themselves just as effectively, and probably more effectively, than we can ourselves. But having the ability to opt in at every point in time is pretty key. So if you really want, as my example was at first going into this, if you really want the artificial intelligence to look at your calendar and realize you've got an appointment with a customer in another state in 2 weeks, and buy a flight for you, optimize and get the cheapest airfare, and buy a flight according to your preferences, and put you in a seat according to your preferences, and get you an Uber to the airport at your desired early arrival time, provide transportation for you when you get back, or arrive at your destination, and then get a restaurant. You have to generally opt in for that. And so you can actually put the limits on it yourself, and no one's going to create profiles to that degree on anybody without some type of buy-in or opt-in. I like that question, though. Good one.
Well, Excellent. And so the next question is, does FSD open up a whole can of security worms?
I think FSD got it. Open up a whole can of security worms. Well, let me tell you. I don't know if it opens up a whole lot more than we already have. It seems like our security concerns are. We have a multitude of security issues right now, and those are only getting exacerbated by some of the current worldwide conditions and the profitability and the nation states that are involved in cybersecurity. Hacking, unfortunately, and bad actors that come in from cyber criminal groups. Actually, we see cyber crime these days. It used to be the big corporate cyber syndicates were into bootlegging decades ago. Now they're into ransomware, which is, according to New York Times, the most pervasive and profitable form of malware. So I think we'll, full service driving. We'll probably see. I don't know that it'll be any more of a escalating issue than we see today, caused by other things like our current COVID-19 pandemic. I will say that, like I mentioned before, full service driving or self-service or auto driving vehicles are definitely going to be creating issues that we'll have to deal with in terms of providing the level of comfort that those cars are really safe and secure. But I think that we'll get there. I think we're just in an environment today where cybersecurity is escalating all the time, and the concerns are going up every day. If you look at the research, that the increase in cyber threats going out exponentially. So I think that we'll be comfortable with the auto driving or full service driving vehicles. Okay, next question from Umesh on the, thanks, this is working pretty well. I appreciate the texting here. The more detailed cyber catalyst designation, sure. Established by Marsh Broker, and you can look up on their site, Marsh Insurance, has pulled together the world's 8 largest cybersecurity underwriters, is what they are. They're actually the ones that make the payout in case there's a cyber breach. Now, how big can a cybersecurity breach be, and how much can it cost a customer? There are some public records on large shipping companies, for example, over $250 million to make a recovery from that ransomware attack. There's a company that I worked with personally, a healthcare company on the East Coast that was hit by SamSam ransomware, and that took them down. And imagine in a healthcare environment where you cannot see customers for a long period of time, a week or two. That's a life and death situation. Not only does it destroy your brand, but the cybersecurity insurance comes in and pays for all that. So the cyber catalyst is a recognition and an actual logo or designation that goes on products that have the designation. CrowdStrike, if you look it up, you'll see CrowdStrike received a couple, HP received a couple. There were 17 that were awarded, but it may entitle customers that use those products to have enhanced terms and conditions. Now, large enterprise companies in the world today, on average, if you look at the Fortune 500, are paying multi-million dollars every year for cybersecurity insurance. So it's a real opportunity to have enhanced terms and conditions that can be really beneficial for those companies in today's environment. If you look at the Ponemon research report, Ponemon did a study here recently on how many companies are buying cybersecurity insurance. Over 90%, I think 92.3, something like that, over 90% are buying cybersecurity insurance because they know the threats are so devastating if a breach is successful. So the Cyber Catalyst says, essentially, these are products that we've looked at that are substantially differentiated and provide helpful characteristics to keeping out bad actors or detecting them if they do get in, and then being able to recover from those attacks and breaches. So it's well documented. It's on the Marsh insurance broker located in New York City, available worldwide, focused on North America mostly, but it does designate products that go above and beyond your typical security protective capabilities. How is AI used to train employee populations on good cybersecurity practices? I like this question too, Umesh. Thanks for that. But yeah, let me tell you, the employee population, the human element, is definitely the least predictable, and so we can actually use artificial intelligence, and we do, to help train and educate our employees. And we do it like this in some cases. We can send out a scenario based on the employee's proclivity to click on certain links, or what they generally like to or will be more deceived by. We can create some fake or pseudo phishing emails, send those out to employee populations to see if they'll bite, so to speak. Now, they're not real phishing emails, so if you click on the link, you do not really invite a hacker into your environment. But we use the artificial intelligence to send out mass emails like that are more customized to what employees might have a tendency to click on. And then they learn, obviously, once they've clicked on that they've done the wrong thing. And then, quite honestly, a lot of companies will make those employees go through some type of remedial cybersecurity education and training. So it is helpful. We also use artificial intelligence to keep out hackers, and we use it all the time, as some of my slides were showing there, for things like anti-fraud protection and protecting our employee populations from emails, spam emails, or ransomware emails that come in. So not only can we use them to train, AI to train, but we also use AI to keep out the bad actors.
Excellent, Bob. Thank you so much. We're almost up on the hour, but it's been information packed as usual. 3 straight years you have delivered awesome content and been a great supporter and friend of the summit and everything that you and HPE have done for our community. We appreciate it extremely strongly. Been great corporate citizens. Thank you so much. And hopefully we will see you back.
Yes.
So thank you, Bob. And yeah. And
you bet. I appreciate it. Thanks for everybody's time. Hopefully you've found this to be educational.
Excellent topic. Lots of great content. Made us think in new and different ways. Take care and have a great day.